Okay, we're continuing with our um, vector of objects sort of tile program. I don't know. I lost I lost control of what parts. I guess this could be part 4, but I don't want to make new slides because I'm not really doing anything new. We're working on this tile set, which contains, well, we've kind of changed that. Instead of 100, we have a vector of tiles, and we've set it up so that it initializes to full and prints for debugging. So what I did is I went to Wikipedia, found the numbers and values of each one. I stuck in some blanks, and then when we run it and compile it, we get here, which again I'm not quite sure is 100 or not. I mean, it kind of looks like 100 or so. So maybe our debugging could use a little help here, just to make sure our life is a lot better. So let's say that if I mod 10 is 9, right at the end of the count, let's stick an end L in there. My sort of style is that if it can fit across on one line for an if, I'll do it in one line. Okay, let's see what we got. Oops. Oh, that's right, because I have a print here. Yeah, I don't have a cout in this, so I think we've done this like 3 times, huh? Okay, we have it in there. Let's test it and run it. That looks a little neater. On a quick glance, I can see, oh, there's a 10 here. That's why these columns aren't perfectly set, but I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 10 is 100. So I do have the full 100 in there, and then like I can see that there's 12 E's and 9 A's, 8 A's. I don't even remember how many it's supposed to be. Anyway, looks good. Matching it. So yeah, making your debugging like kind of readable helps. But the other thing that we want to do, and we even listed it on our slides here, is we want to, well, count the totals for each letter. But let's start off by just counting the total number of tiles, and let's put that in our debugging. I guess we can either skip a line or move to the next line depending on if there's exactly 100 or not. And all right, since we have these nice vectors, let's use its value in there to tell us. All right, total tiles equals 100. So it looks pretty good. But the trouble is, like, they're in order, right? If first I'd start out by pulling out E's, and someone would end up with 7 E's, and the other one would end up with what, 4 E's and a bunch of A's or something like that. So let's shuffle them, okay? After we make the tiles, we're always going to want to shuffle them. So I'm going to put a shuffle down here. And we'll go out into our header file. Oh, wrong header file. Go out into our header file, and we'll put our shuffle here. Now, last time I put make tiles here, but I don't want anyone to be able to make any tiles. Yes, they can shuffle them, so I'm going to put shuffle as part of the interface. But I think that this make tiles function really should be part of the fill, and perhaps fill would have some parameters of a style of way to fill it or whatever, using different rules. Anyway, we're not going to worry about that. But yeah, this makes a better private function. Added some pieces. Does it still compile? undefined reference to shuffle. So, oh yeah, I have to put in the prototype. I put in the prototype. I need to put in the definition for shuffle. It's a member of the tileBag class. It's called shuffle. Now, in order to shuffle it, well, I guess I could manipulate the array, but you know what? I'm using vectors. Why don't I go and use the built-in functions? The built-in function is called random shuffle. Now, when we look it up, we see that we need iterators pointing to the beginning and the end. So I need to shuffle from the beginning of the bag to the end of the bag. All right. I also happen to know that random shuffle uses the rand function, I suppose, unless we say otherwise. So I'm going to pop over to main. Up here in the beginning of the main, I'm going to do my srand times 0, because right, I only do it once, and I might as well do it up here. So I'll include for srand, and I'll include ctime for the time method, and let's see what happens. Random shuffle was not declared. Right, random shuffle is in algorithm, right, that part of the STL called algorithm. And there we go. Hey, whoever pulls first gets the blank out. Still have 100 tiles. Right, still looks good. Right, trying to compile it, run it again, just to see we get something different. Yep, we get something different. So now, right, I have my shuffled tiles for going on there, and putting them in. Now this shuffle, again, remember, doesn't matter how many tiles there are, because with more tiles or less tiles, it's still going to use the beginning and the end. So nothing is tied here to the amount of size. So again, remember, random shuffle, right, requires, right, an iterator to the beginning of what we're shuffling, an iterator to the end of what we're shuffling, right, and it lives in algorithm, right, the algorithm part of the STL. And again, I'm going to always shuffle it as part of my, right, filling it with tiles. Now, okay, so I'll stop here, and then we'll move on to, I think we're up to sort of perhaps thinking about the tile rack class, which is going to be very similar. So I may copy some of the code over before we do the next piece.